Hello everyone, we are from Group 11 and today we will be presenting about the application of physics in our daily life, or to be more specific, in our respective programs, which is biotechnology and also MCG. The first topic chosen for our group is rotational motion. So to explain briefly about the physics concept, rotational motion occurs when an object rotates about an axis and every point of that object follows a circular path. So one of the application of this physics concept in biotechnology program is regarding centrifugation. So what exactly is centrifugation? Well, to put it simply, it is a process of separating different substances with different densities by spinning them at high speeds, which in this case is the application of that physics concept.
For this slide, I will explain rotational motion. Rotational motion happens when an object rotates around an axis and every point moves in a circular path. In computer graphics and mathematical modeling, rotational motion is very important. It is used to control object orientation, camera movement, animation, and simulations. This concept helps make movement in graphics looks more realistic and smooth. Next, this slide is about rotation metrics. Rotation metrics are mathematical tools used to rotate objects in 2D and 3D space. They are commonly used in software like OpenGL, Unity, and Blender. Rotation metrics help control object direction and camera rotation. They are also used in game physics engines to simulate realistic motion. For this slide, we focus on rotational motion in MCG. In MCG, rotation metrics and quaternions are used to rotate 3D models. Angular velocity controls how smooth the animation looks. This is very important in games and animations. These techniques are used in Unity, Unreal Engine, Blender, Maya, and CAD software. The core equation is omega equals d theta over d time. These slides show how rotational motion is applied in graphic hardware. One example is GPU cooling. Rotating fans are analyzed using rotational dynamics, angular velocity effect, airflow, and heat removal. Rotational motion is also used in rendering, such as texture rotation, particle systems, and particle animation. This application help improve performance and visual quality.
Moving on, the next topic we chose is solid and fluid. So for biotechnology, the physics concept highly relates to osmosis, where a difference in solute concentrations separates a solution. We can see this happening in figure 1, where some of the potato strip shrink or enlarge depending on the concentration of the solution.
Solid and fluid in computer graphics are used to model real-world physical behavior. Solid mechanics deal with rigid objects that keep their shape, while fluid mechanics studies liquids and gas that can flow and change shape. This concept helps create realistic motion and visuals in animation and simulations. Solid mechanics focus on rigid body modeling. It is used to simulate the movement, collision, and interaction of solid objects. Examples include buildings, vehicles, and objects in games. Fluid mechanics simulates liquids and gas such as water, smoke, and air. It is used to create realistic fluid motion in movies, games, and visual effects.
So for the last physics concept our group has chosen is energy in thermal process. So in biotechnology, this concept is applied in autoclave sterilization, which is one of the sterilizing and disinfecting methods used for objects. It is through the use of heat in the form of steam, which it then allows to decontaminate all parts of an instrument.
This slide explains energy in thermal process in mathematics and graphic computer. In computer system, electrical and mechanical energy are converted into heat. This heat affects computer graphic hardware and simulation, especially performance and efficiency. Key thermal process. First, energy conversion. In computing systems, electrical energy is used in computers is converted into heat. Excess heat can reduce performance and cause thermal throttling. Number 2, heat transfer modes in graphic hardware. Heat is transferred through conduction, convection, and radiation. This process helps control temperature and keep hardware running safely. Energy in thermal process. Thermal management of GPU and CPUs. GPU and CPU generate heat during computation. This heat must be removed to avoid overheating and system damage. First law of thermodynamics. The first law explains that energy is conserved. Heat and work are related through energy transfer in the system.